learned that Amazon CloudWatch enables auto-scaling to dynamically determine the right time to scale an auto-scaling group. Autoscaling is a web service designed to launch or terminate Amazon EC2 instances automatically based on user-defined policies, schedules, and health checks. Setting up autoscaling involves 3 steps. The first step is to create a launch configuration. You will notice the options specified here are the same you would have used to create a new instance. In other words, at this stage, you help autoscaling determine what kind of instance should it create the next time a scaling requirement arises. An autoscaling group is a logical group of autoscaling instances. When an autoscaling group is created, we would have to specify the VPC and subnets autoscaling should use. We also specify the minimum and the maximum sizes of the group. Autoscaling will ensure that minimum number is maintained by creating new instances to maintain the minimum number if needed. Desired capacity is an optional configuration. It can be used to specify the optimum number of instances needed. If a desired capacity is specified, then the autoscaling group would start with the desired number of servers in the group. If a desired capacity is not specified, then the minimum size becomes the desired capacity. The maximum size refers to the limit of the number of servers in the group. Depending on the traffic directed to the application, Amazon EC2 instances can now scale between the minimum and maximum numbers. The final part of autoscaling is to define when should autoscaling scale. Autoscaling can scale based on time defined as a scheduled event or based on an Amazon CloudWatch metric that could be more dynamic. In this example, you see the scale-out operation first creates an instance before adding it to the group. Similarly, a scale-in operation first detaches the instance from the group before terminating it. In summary, Amazon CloudWatch, autoscaling, and ELB can be used to work together to ensure application availability. Now let's look at a demo to reinforce what we have covered. Let's see how ELB, autoscaling, and CloudWatch can work together to scale an application. On the Amazon EC2 console, we have created a web server which can be accessed using its public IP address. Let's now create an AMI which will be used a little later in an autoscaling group. After giving the AMI a name and a description, let's click on Create Image. AMI creation will take some time, and its progress can be verified by clicking on AMIs on the EC2 dashboard. Let's now create an application load balancer. We start by giving the load balancer a name. We can specify if the load balancer should be publicly accessible and what port should be open. The VPC and the public subnets for the ALB are defined next. In step 3, we select an HTTP security group to permit web server traffic. In step 4, we create a target group that will consist of Amazon EC2 instances from the autoscaling group. Targets will be later registered once the autoscaling group has been created. After reviewing the options, we click on Create. Let's verify if the AMI is ready. While the AMI is being created, let's proceed to the autoscaling configuration. We start by creating a launch configuration and then proceed to select the web server AMI. Let's click on Next, Configure Details, and give the launch configuration a name. We then enable detailed monitoring, and since the web service will not be publicly exposed, we can choose the Do Not Assign a Public IP Address to Any Instance option. Let's click on Next and select the HTTP security group, and finally click Create Launch Configuration. We then proceed to create an autoscaling group. Let's define the group size as 2, followed by the VPC and the private subnets for the web service. Under Advanced Details, let's enable the option to receive traffic from the ELB. We also enable ELB health check and detailed monitoring. In the Create Autoscaling Group section, let's create an autoscaling policy to scale between 2 and 6 instances. In the Increase Autoscaling Policy section, let's define the average CPU utilization to be greater than or equal to 60% and name the alarm as scale out. We then specify the action to add 1 instance and the warm-up period as 60 seconds. We similarly create a scale-in alarm with the CPU utilization to be less than or equal to 20%. Let's call the alarm scale-in. Let's choose the option to remove 1 instance if the condition is true. We then tag the autoscaling group and finally click on Create Autoscaling Group. Autoscaling should now start creating 2 instances, and it should take some time for it to be ready. You can check the availability of the 2 instances under Autoscaling Groups or Instances on the EC2 dashboard. Let's click on Target Groups and make sure the targets are healthy. After verifying the status, we can go to the load balancers and access the ALB by using its DNS name. We could compare the instance ID to make sure the ALB is pointing to the newly created instance. let's add some load on the backend instance. This should take some time to reflect in CloudWatch as an alarm. You will notice the alarms transition from scale-in alarm to an OK state, and finally the scale-out alarm would be triggered. It could take some time for the scale-out alarm to be triggered. Once the scale-out alarm has been triggered, auto-scaling should add another instance to the auto-scaling group. Let's check the auto-scaling group to verify if a new instance has been created. This concludes the auto-scaling demo. We have now completed Module 5. Please test your knowledge by answering the questions on the screen. Congratulations, you have now completed the Awesome Day online conference. Now that you understand the basics of AWS, it's important to continue learning, and there are a few things that I would like to ask you to do. To gain some hands-on experience, try the complimentary AWS introductory labs. These labs provide you with hands-on practice in a live console and generally take less than 30 minutes to complete. There are also a large number of advanced labs if you would like to dive into a bit more detail. Please go to amazon.quicklabs.com. Once you're on the amazon.quicklabs.com login page, please click on